Hello. Hello. Am I audible?
Yes, ma'am.
Yes, ma'am.
Hello. Shall we start? Should I start?
Yes, ma'am.
Yes, what was the last point? Can anyone please tell me? Am I audible clearly? Am I audible?
Yes, ma'am.
Please check whether my screen is visible or not.
Okay. So let's start. Actually, this is a practical session, but we cannot continue the practical session because still we have not completed any of the algorithm or any of the concept on which you can write the programs and do the practical. So let's cover the theory part first. I will cover the theoretical part which is required for your first assignment, and then next practical onwards you can do the practical. Okay. So I think we have finished with the basic concepts in hashing. We have seen the definitions like hash table, hash function, bucket, collision, probe, and overflow. Okay. And we have also seen the advantages of perfect hash function. We have seen the definition of perfect hash function.
Collision.
Then what is collision? Yes. Then yes, now today we are going to study the different parts of different types of hash functions. Okay. So there are total 5 types of hash functions. Division method, multiplication method, extraction, mid-square method, and folding and universal method. Okay, so let's see one by one. So division method, in the division method, this method depends upon the remainder of the division. Okay, so for example, let's see if your record is 54, 72, 89, 37. Okay, and you need to place this record in your hash table. This is your hash table from 0 to 9. 0, 1, 2, 3, 4, 5, 7, 9. Okay. Now, if you want to check the index value of the hash table on which you are going to store this number, and if you are using the division method, just divide and let's check the hash function first. Hash function given is h of key is equal to record That is this number mod table size. Table size. Okay. So your first number to find out the H key, that is index key. Suppose your first number is 54. 54 divided by 10. Your answer division remainder value is 4. So at the location 4, index 4, you need to place 54. Okay. So likewise 72 divided by 10. It is equal to 2. So place 72 at index 2. 89 divided by 10 is equal to 9. So place 89 at 9. Okay. And 37. 37 divided by 10 is equal to 7. So place 7 at index 7. Place 37 at index 7. Got this? This is a simple division method. Okay. Got it? Now my voice is clear, I think.
Yes, ma'am.
Yes, ma'am.
Yes? Okay. So this is about the division method. Okay. After that, next method is the multiplication method. Now for the multiplication method, you have to take a constant value, like that constant value should be, or range of that value. Range of that value should be greater than 0, less than 1. Okay. And then extract the fractional part of k of a. K means the key. Fractional part like k of a. K is the key. Okay. Now let's see how it works. Okay. You need to multiply this fractional part by the number, whatever the number. You need to multiply this number with this fraction. Okay. So your function can be h of k, that is to find out the index where you are going to store that number by using the multiplication method. For that, I'm going to write a function as h of k is equal to m ka. This is small k. Okay, this is the fractional part. And one scientist, that name is as Donald Kunt. Wait a minute. Donald Nutt. He suggested that to use the value of a as a is equal to 0.816033989887. He recommends to use the value of this constant as 0.6180339898. Okay. Got it? Now let's see how you are going to find the index value. Now suppose your value of key is 107k. This is the number 107. You need to place this into the table. So 107, and assume the value of m is equal to 50. So you can calculate the value of h of k, that is the index for this k is 107 into bracket this is k and this is a. So value I am going to write it here. First calculate the k of a. Ka 0.6180339897. Can anyone please tell me the answer? Value of Ka? Yes. What is the answer of this multiplication? Someone please quickly do the calculation on the calculator. Tell me the answer. 107 into
66.12.
66.12.
30.
Okay. So here, now what is the fractional part of this Ka? You have to consider only the fractional part, not the whole answer. Okay. As the rule given, you need to consider only the fractional part of the multiplication of Ka. Okay. So what is the fractional part of this? Fractional part is this 12.12. So 0.12 is the fractional part. Now next step is, what is the value of m? Value of m is 50. So 50 into fractional part, that is 0.12. What is the answer? Check the answer. I think it's 6.
6.
Yes, 6. So at index 6, you can place 107. That is your number. Got it? Got it? Okay. So this is the multiplication method. Now after multiplication method, next method is extraction method. So what is the extraction method? Actually, in this method, from the whole number, some digits are extracted from the key to form an address location in the hash table. For example, suppose your number is 4, 9, 7, 8, 2, 4. Okay. So the first number, third number, and fourth number, that is 4, 7, 8. These 3 locations are extracted, numbers from these 3 locations. Third location, first location, third location, and fourth location. These numbers are extracted to form the key. Okay. And your key or your hash table size is suppose you can consider it as a 1000, like 0 to 999, 0 to 199. This is the size of your table. This is the simple extraction. Okay. Now after extraction, next is mid square. Mid square. Now mid square means what? Square the key. Square the key means extract the middle part of the result, and then this will indicate the location of the key element in the hash table. Okay, that means if the key element is a string, then it has to be you need to pre-process that into the number. Okay, suppose your key is 3111. Turn off your mic. Who is talking? Who is talking? Turn off your mic. Okay. Suppose this is your key, 3111. Okay. You have to take the square of this. 3111. What is the square? Yes, tell me the answer. Yes, what is the answer? 7?
9678.
9678.
321.
9678 321.
Yes. Okay. So from this answer, you need to extract the middle part of the result. Okay. So what is the middle part of the result? Middle part is 783. So in the hash table of size 1000, you need to place this value, that is key 3111, this key at position 783. Got it? This is the mid square. Take the square and take the after getting the answer of the square, extract the middle part of the result. Okay, got this? Yes?
Yes,
Yes or
ma'am.
no?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now next method is folding method. Okay. Now folding method. Now again there are two folding techniques. First technique is called as the fold shift. Fold shift. And second is the fold boundary. Fold boundary. Let's see both. First, I'm going to explain the fold shift. Now, fold shift means exactly what? Now, suppose my number is 3, 4, 5, 6, 7, 8, 1, 2, 3. This is total 9-digit number. Now, what I'm going to do is I'm going to divide this number into three parts. This is the first part, 345, and 123 is the second part, and this is the middle part, 678. Now what I am going to do is I'm going to take the addition. 345, this is the first part, then middle part is 678, and the last part is 123. Take the addition of these three numbers. What is the addition? Can you please do the addition?
1146.
Yes,
1146.
1146. Yes, correct. So just discard this 1 and take these three numbers, 3-digit number 146. This will be your index. At this index, you need to place this number. This is called as the fold shift. Got this? That means what? Key is divided into separate parts, and each and every part should be of same size. Okay, suppose your number is 4, 5, 6, 7, 8, 1. Now you should have to divide this number into three parts with 2 digits. Okay, so 45, 67, 81. So just take the add this numbers 45, 67, 81, and whatever is the addition, again discard the, if it is a 3-digit number, you have to discard the first last hundredth place number and take the last two numbers. That will be your index. This is the fold shift. Got this? It's a simple one. Now after fold shift, one more technique is there, that is called as the fold boundary.
मैम
Yes.
मैम फोल्ड शिफ्ट में मैम कितनी पेयर बनाना है? हमेशा 3 ही पेयर बनाना है?
Yes, yes.
Okay.
Left and right and the middle one. Actually the concept is you should have to left parts and shift the left part, right part separately, then take the addition of left and right part, and in the addition again add the middle part also. Actually this is the main concept of shift fold. So you have to divide the number into three parts.
मैम
Yes.
7 डिजिट का हुआ था 7 डिजिट का हुआ था
So first and last part should be of equal digit, and middle one is of the remaining digits. Okay.
ओके
So shift boundary. Now suppose your number is again you can take the same number 3, 4, 5, 6, 7, 8, 1, 2, 3. Okay. Now in this method the key is again divided into separate parts. The leftmost and the rightmost parts are folded. Okay, on the fixed boundary. Okay, folded means what? The digits are you have to reverse the digits. Like this is the first part 3, 4, 5. This is the last part, that is 1, 2, 3. So just shift the digits here. So after shifting the digits, number is 5, 4, 3. Keep the middle one as it is, like 6, 7, 8, and then this last, that is the rightmost part, is again you need to fold it. Fold it means you have to reverse it. So the answer is 3, 2, 1. So add these two numbers. Okay. So what is the answer?
1542.
1542. Discard this one. This is your index 542. Got this?
Yes, ma'am.
Yes. So these are the techniques. We have seen division, multiplication, extraction, mid square, folding. Okay. Now, actually, Dhanashree is asking something. No? What is the meaning of? Yes, what is the question? Okay, suppose you have the okay, synonym. Synonym. Actually, the meaning of that meaning is, suppose in your hash table, uh, sorry. Yes, just wait a minute. Now, if you check, suppose this is your hash table. Okay. Now for this hash table, if the first number is 25, which already placed at index 0, and suppose one more number I have like 50, 50 mod 5 is also 0. No? So this 50 and 25 are called as the synonym. That means they have the same index, same key. Okay. So 50 and 25, that is equal index. They are sharing equal index. Got this? Yes? Okay. Okay. So next, after this, next part is, let's see some advantages or properties of the good hash function. Now, there are certain rules to write a hash function. How you are going to write a hash function, like h key is equal to whatever the number and mod 5, mod 10, like this. So, for rules for choosing the hash function, the first rule means your hash function should be simple in computation. You should have to easily calculate the value of the index to place that number into particular location in the hash table. Okay, so number of collisions should be less while placing the record in the hash table. So ideally, no collision should occur, but if the collision is there, then number of collisions should be less. Such a function is called as the perfect hash function. If collision is not there, that means your function is perfect hash function. Okay, so hash function should produce such a keys which will get distributed uniformly over an array. You should get uniformly the number of indexes. The hash function should depend on every bit of the key. Thus, the hash function that simply extract the portion of the key is not suitable. Okay, so this is about the hash techniques. Now after this, next point is how to resolve the collision. Okay, as we have already seen the problem of collision. Okay, what is collision? Can anyone please tell me what is meant by collision? Yes, what is meant by collision?
collision ma'am, collision मतलब suppose in a stack, suppose at index 0 वहाँ पे वैल्यू प्लेस की है 25 एंड अगर एक दूसरे एक वैल्यू है जो मतलब इंडेक्स 0 पे आने वाली है तो उसको बोलते हैं कोलिजन. सो इन दैट केस वी कैन फॉर्म लिंक लिस्ट, वी कैन फॉर्म अ चेन.
Yes,
मतलब सेम इंडेक्स पे आ रही है दूसरी वैल्यू, उसको कोलिजन बोलते हैं.
yes, exactly. And if collision occurs, then it should be handled by applying some techniques, and those techniques are called as the collision handling techniques. Okay, so
Yes.
okay. Now there are two types. Basically, there are two types of collision handling techniques. One is open hashing. One is called as the open hashing
And close hashing.
and closed hashing. Now, open hashing technique is also called as the chaining. Okay, and in closed hashing, again there are three different types. First is the linear probing. Next is the quadratic probing. And double hashing. So these are the types of collision resolution techniques. Okay. So let's see what is meant by open and closed hashing. The open hashing means what? It is actually it is also called as the separate chaining, and closed hashing is called as the open addressing. Closed hashing is called as open addressing. Okay, whereas open hashing is called as closed addressing. Okay. So the difference between the open hashing is the difference between this open hashing and the closed hashing is that in open hashing the collisions are stored outside the table, and in closed hashing the collisions are stored in the same table at some other slot. This is the difference, major difference between open hashing and the closed hashing. Just remember this difference. In open hashing, the collisions are stored outside the table, whereas in closed hashing, the collisions are stored in the same table, but just only the different slot is there. Okay. What is this question, Dhaneshwari? Difference between synonym and collision. Yes, who will give the answer of this? Yes. What is the collision and synonym? What is the difference? Just please can anyone please tell her the difference? Yes, Naneshwari, you tell me what is collision? Naneshwari, tell me the definition of collision.
सेम इंडेक्स जर मागत असेल तर कोलिजन असते.
सेम इंडेक्स मागत असेल तर कोलिजन आहे. म्हणजे कोलिजन हे काय आहे? ही एक कन्सेप्ट झाली ना. आणि जे दोन नंबर सेम आहेत, ज्या दोन नंबरची इंडेक्स सेम येते ते दोन नंबर म्हणजे काय?
सिनोनिम.
समजलं का आता?
अच्छा, हा समजलं.
बरोबर ना? कोलिजन म्हणजे काय? कोलिजन ही एक कंडिशन आहे. ती कंडिशन म्हणजे काय? दोन नंबर जर एकाच इंडेक्स तुम्हाला डिमांड करताय, दॅट मीन्स कोलिजन इज ऑकर देअर. ओके, बट synonym means what? That two numbers, they are a synonym. मतलब I think meaning the numbers which demands for the same index value, those numbers are called as the synonym. Okay.
Yes, ma'am.
Okay. Now let's start the chaining. What is meant by chaining? Now again, when you understand the concept of this chaining, again there is different methods of handling the collision or for resolution of the collision. First is the chaining without replacement and chaining with replacement. Okay, now let's see what exactly the meaning of with replacement and without replacement. Okay, the first start with the chaining. Chaining means what? It is the open hashing. It is open hashing. Open hashing. It is called as chaining. Okay. Now first we are going to see chaining without replacement. Okay. So now when you use this method, you need to add one additional field with the data. That data is called as the chain. Like this is the index. Index. The data which you are going to store at particular index and the chain. What is this chain? Let's see. Now suppose for example my data is 131, 3, 4, 21, 61, 6, 71, 8 and 9. Okay, now I have to place this data in a table with method by using the method chaining without replacement. Okay, so this is the table, this is the index, this is data, and this is chain. So suppose your hash function is again mod 10. Okay, so 131 mod 10, and your table size is 10. So you have to take the index from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so 131 mod 10, which is equal to, what is the answer of mod function?
13.1.
Who is this? Yes, what is the answer? 131 mod 10. Mod means what? It's a reminder value, na? Yes, 1. So answer is 1. So at position 1, we need to place 131. Okay, so let's place 131 at index 1. Now take the next number, that is 3. 3 mod 10 is equal to 3. Correct? Is this correct? Yes? Yes or no? Is it correct?
Yes, ma'am.
Yes. So place at index 3, place number 3. Then 4 mod 10, which is equal to 4. So at 4, index 4, place number 4. Now the next number is 21. What is the mod value of 21?
One.
Now again it's 1. Again it's 1. But at position 1, that is at index 1, we have already placed 131. And this is the actual position of 131. That is, the index of 131 is also 1. And the index for 21 is also 1. So and the method we are using is chaining without replacement. We are not going to replace that number. So what you can do is, whatever the index which is empty after 1, so you can place 21 at that index. So though for placing 21 in the hash table, though you get the index as 1, but as index 1 is not empty, find out the next index after 1 which is empty and where you can place 21. Okay, so after 1, if you see the index 2, that index 2 is empty. Okay, so I'm going to place this 21 at index 2 because it is the empty place. Okay, but actual position of 21 should be 1, no? So I'm going to provide here chain at index 1 here in the chain table as 2. That is, although you need to place 21 at index 1, we are providing the link or providing a chain number 2, and you are going to place the value 21 at index 2. Got this? Got this? Yes?
Yes, ma'am.
Yes, ma'am.
Yes? Okay. Now let's see the next number. Next number is 61. Now 61 mod 10. The value is 1. Now again it's 1. That means again you need to place this 61 at 1, but one place is already occupied by some other number. So you need to find out some other empty index to place 61. Now what is the next empty index? Now next empty index is, if you see 2, 3, 4, all are occupied with their proper data. Okay, so the next empty index is 5. So you need to place this 61 at position 5. I'm going to place it 61. Okay, now if you place, now this 5, index 5 is not the proper place of storing this data. Actually the proper place of storing 61 is 1 only, but we have already placed the data at index 1. Okay, now after that, what we have to do is, you have to provide the chain for this number 61. That is the reference. Now if you see the index 1, now what is the index of 61? Index 1. Now what is the chain of index 1? It is 2. Now if you see the index 2, now at index 2 you need to provide the chain as 5 for reference of number 61. Got it? That means by referring this chain, you will find the number 61, which has actual index as 1. Got this? Is it clear?
मैम इंडेक्स 0 क्यों नहीं ले सकते?
0 का अगर 10, अगर आपके पास नंबर है सपोज 30, okay, you need to place 30 in the table. So 30 mod 10 is equal to 0. So you get the index 0, so you can place 30 here. It's
जैसे
simple.
अभी डेटा में अपने पास 30 है नहीं, तो 0 इंडेक्स फिलहाल एम्प्टी है.
हाँ है ना. अगर आपके पास सपोज 0 इंडेक्स है, लेकिन आपने को क्या करना है कि नेक्स्ट एम्प्टी इंडेक्स यू हैव टू रेफर ना. नेक्स्ट एम्प्टी इंडेक्स नहीं है ना, हम सीरियली जाएंगे ना. अगर 9 के बाद का नेक्स्ट एम्प्टी इंडेक्स 0 आता है, अगर 9 तक आपके पूरे स्टोर है टेबल और 9 के बाद भी एक नंबर आपके पास बचा हुआ है, और उसके लिए इफ यू वांट टू फाइंड आउट द एम्प्टी प्लेस, देन यू नीड टू प्लेस दैट नंबर at 0th location. Got it?
Yes, ma'am.
No, you cannot. You have to find out the next empty position. ओके. 9 नंतरची नेक्स्ट एम्प्टी पोझिशन कोणती येईल? 0च येईल ना. तुमचा टेबल साईज काय आहे? 0 to 9 आहे. येस. ओके. नाव आफ्टर 61 number is 6. Clearly the value is 6. You can place here. Then after that the value is okay, I will erase this data. Now next number is after 6 is 71 now. Now 71 mod 10 is again 1. But again same situation is there. Index 1 is not empty. So after this 6, what is the next empty index? It is 7.
7.
Yes. So yes. So place 71 at index 7. Okay. Now okay. So where should I mark the index number 7 in the chain table? Can anyone please answer?
Index
5.
Index.
At index 5, like this position here. I have to place 7. Got it? Okay. So after that, number is 8 and 9. So 8, I can place it at location 8, and 9, I can place it at location 9. So this is your table. Now let me rewrite this table. This is index, data, and chain. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So at 0 there is no number. 131 is here, 21 is here, 3 is here, 4 is here. At 5 we have placed 61. At 6, 6 is there. At 7, 71 is there, 8 and 9. So first index 21's chain is 2, 61's chain is 5, 71's chain is 7. So whatever the remaining positions in the data slot and the chain slot, you need to place -1 there. That indicates this as an empty slot. 21, sorry, -1. -1, -1, -1, -1. Got this? Got it? The concept of chaining without replacement. Got it?
Yes, ma'am.
Yes or no?
मैम
Yes.
वो 7 5 के अंडर क्यों नहीं आया? वो गैप मतलब -1 के जगह क्यों नहीं आया?
कौन से -1 की जगह?
वो चेन
7 ना?
में ना। हाँ
हाँ. मतलब कौन से लोकेशन पे? फिफ्थ के आगे, फिफ्थ इंडेक्स के आगे हमने 7 लिखा है, क्योंकि हमने 71 जो है वो 7th इंडेक्स पे स्टोर किया है, इसलिए 71 के पहले अपने को 6 मिला था. सो वी हैव टू प्लेस 6 इन द इंडेक्स एट द इंडेक्स ऑफ 6. तो नेक्स्ट रिमेनिंग इंडेक्स कौन सा है? 71 के लिए. एक्चुअली 71 का इंडेक्स क्या आता है? 1 आता है, isn't it? Yes, but 1 is not empty, no? So which is the remaining, which is the empty location to place 71? It is 7. So we have placed 71 in at index 7.
हाँ
Yes,
वो
and
ठीक है मैम,
we have
लेकिन
written
वो
that number in the chain of 5.
हाँ वही पूछ रहा था 5 के यहाँ पे क्यों, मतलब 3 के लाइन 3 के यहाँ पे क्यों नहीं आया?
3 के लाइन पे कहाँ, कैसे करेंगे हम लोग? हमने क्या किया है कि अभी आपने अगर चेक किया कि 71 नंबर का इंडेक्स फाइंड आउट करना है आपको. 71 कहाँ पे होना चाहिए? एक्चुअली 1 पोजीशन पे होना चाहिए. आपने चेक किया 1 पोजीशन पे क्या है, 131 है। ओके, सो 131 चाहिए क्या, नहीं, अपने को क्या चाहिए, 71 चाहिए। यू आर फाइंडिंग, यू आर सर्चिंग फॉर 71। ओके, सो 131 के लिए चेन क्या दिया है, 2 पे अगर आपने देखा तो 2 पे तो 21 है, अगेन यू आर नॉट गेटिंग 71, तो 21 का आप अगेन चेन चेक करो, तो 21 का चेन क्या है, 5 है, तो 5 में अगर आपने चेक किया तो 61 आता है। ठीक है, तो 61 आता है, लेकिन आपको 61 नहीं चाहिए, आपको 71 चाहिए। तो 65 के चेन में क्या दिया हुआ है, 7, तो 7 पोजीशन पे आपने 61 स्टोर किया है। अगर आप 7 नंबर आप 3 पे लिखते हो तो आपको अगर यहाँ पे 3 पोजीशन है क्या चेन में, नहीं है ना, तो आपको उसका ये चेनिंग है ना, आपको लिंक मिलता है, लिंक एक इंडिकेट होता है कि कहाँ पे एक्चुअली वो नंबर स्टोर किया हुआ है।
ओके मैम, हाँ।
गॉट इट नाउ, और स्टिल कंफ्यूज्ड?
गॉट इट मैम।
गॉट इट, श्योर?
यस मैम।
Okay, so this is chaining without replacement. Now next is okay. Now next is chaining with replacement. Replacement मतलब क्या? Now suppose in the same table, now here I have placed 21 at index 2. Okay. Now suppose in my number list, if one number is 22, now 22 mod 10 is equal to 2. So actual index of 22 is 2. That means at index 2, you have to place 22. But you have already placed 21 there, isn't it? But for 21, 2 is not a perfect position. For 21, you need to, your index is 1. But as at one index, you already placed 131 and the next empty position is 2. That's why you have placed 21 at index 2. But again, there is a number 22 and you need to place that 22. You need to place that 22 at 2. That means here you have to replace this 21 by 22 and you have to shift this 21 at some other place, because for 2 is not the perfect index, 2 is not the perfect index of 21, but it's a perfect index of 22. This is the concept of chaining with replacement. आपको replace कब करना है? Where? When should you can replace the number? Okay. समझ में आ गया? Is it clear now? We are going to see the example of with replacement also. Is the concept clear? Yes or no? Give the answer. Yes or no?
Yes, ma'am.
मैम रिपीट करो.
Yes, yes. I am going to give the example. Let's see the example. Suppose my numbers are 131, 21, 31, 4 and 5. Okay. Now this is index 0, index this is number and this is the chain. Okay. Now let's take the same hash function. So 131 mod 10 is equal to 1. So again 0, 1, 2, 3, 4, 5, 6, 8, 9. So at 1, I am going to place 131. Okay. Now next number is 21. Now again index is 1. So index 1 is already occupied by 131. So take the next empty location, that is 2, and place 21 there. And write that index in the chain. Okay, got it? Now after that again 31 is there, which is also having the same index, that is 1. So next empty location is 3. Place 31 at index 3, and whatever the index 3, you need to place it in the chain part of 2. Got it? So after that 4 is there, index 4 is 10 is equal to 4. So here 5 mod 10 is equal to 5. Here 5. Okay. Now after this, now suppose your next number is 2. 2 mod 10 is equal to 2. Now you need to place 2 at position 2. But if you see the table, at position 2, you have already placed 21, isn't it? So here, I need to remove this 21 from the table. Got it? Because for placing number 2, the actual position to place value 2 is index 2. Therefore, you should have to place 2 at index 2 only. That's why I am removing this 21 here from here and placing 2 at index 2, and I will search the next empty position to place 21. So next empty position to place 21 is 6. So I am going to write 21 at index 6. Okay. Now here 21 at index 6. Okay. So I need to change the position in the chain slot also for 1. So previously we have stored 21 at index 2. That's why we have written in the chain slot as 2. But here I have to change it as 6. Okay. Got this?
Yes.
Yes, ma'am.
Yes. So this method is called as the chaining with replacement. You can replace, but the number we are going to replace, that index should have the proper index. Got it? Okay. Now we will see more examples of this chaining with replacement and chaining without replacement. Okay, in the next practical. Okay. So let's stop today. If you have any doubt, you can post your doubts on our DSA group, not the official group. Okay. Okay. So should I stop my sharing?
Yes, ma'am.
Yes,
Okay, ma'am.
Okay.
Goodbye.